When solving logarithmic equations, we either want to write them as the logarithm base of a quantity is equal to the logarithm same base of a quantity and use the property that logarithms are 1 to 1. Or we want to write them as logarithm base of a quantity is equal to a number and rewrite it out of logarithmic form into exponential form. In this example, we have the logarithm base 7 of the variable quantity 2x minus 9 minus the logarithm base 7 of the quantity x minus 1 is equal to 0. We could actually solve this one in either of the two ways, but because the right-hand side is 0, this one would be much easier to do if we added the logarithm base 7 of x minus 1 to both sides and rewrote it as logarithm base 7 of 2x minus 9 is equal to logarithm base 7 of x minus 1. Now we have the logarithm base 7 of 2x minus 9 taking up the entire left-hand side of the equation, and then on the right-hand side of the equation, logarithm base 7 of x minus 1. Now remember, since logarithms are 1 to 1, if I have the logarithm base b of a is equal to the logarithm base b of c, that means that a had to be the same value as c. So using that in solving my equation, I have the same base of 7, and the logarithm base 7 of these two quantities are equal. That means that 2x minus 9 has to be the same value as x minus 1. And now I can solve this algebraically. We'll subtract x from both sides and get x minus 9 is equal to negative 1. Then add 9 to both sides to get x is equal to 8. Now remember, that's a possible solution, but because logarithms have a restricted domain, they're only defined over the positive numbers, we need to always make sure that we check our solutions for logarithmic equations in the original equation to make sure that it makes it true. So here we have logarithm base 7 of, take out the x and put in 8, so 2 times 8 minus 9, minus the logarithm base 7 of, take out the x and put in 8, minus 1. I want to know if that'll come out to be 0. Well, inside the parentheses, you need to do the operations first. So I have 2 times 8 is 16, minus 9 is 7. So that's logarithm base 7 of 7 minus log base 7 of 7. 8 minus 1 is 7. Does that come out to be 0? And remember, logarithms are exponents that you put on the base to create the value. So the exponent I put on 7 to get 7 is 1, minus, again, 1. Is that equal to 0? And yes, 1 minus 1 is 0. So that checks. And so x equal 8 is the solution to our original logarithmic equation.